Dear student, today we'll learn a volume of distribution. Volume of distribution is defined as the volume in which the amount of drug would be uniformly distributed to produce the observed blood concentration, and which is denoted by VD, volume of distribution. We'll see an example. Consider two containers is that one is the A and second is the B, which having the same volume of a liquid in it. Now consider the container A, which having the same volume of liquid, container B also have the same, but the difference is that container B contains the extra material in that, which will at the bottom you can see here. For example, you take it is a charcoal, clear, which having a property of adsorption of material from the liquid. So now what we will do now, if you are adding the 1 gram of drug, any drug, 1 gram of drug in the container A and the 1 gram of the drug in the container B, which having the same amount of drug in the both the container. Now what will happen, after determining the amount of drug present in this liquid with the help of analytical method, we come to know that the container A shows the 100 microgram per ml and container B find the 50 microgram per ml. Now why this is the difference? In the case of container A, there is no extra components which absorb the drug. In this case, it contains the extra components, for example charcoal, which having a property of adsorption. So what will happen, the amount of the drug which is present in this liquid, from that some of the drug will get absorbed on the surface of the charcoal, or that may be penetrated into this charcoal, due to which the concentration of drug in this liquid becomes less. So decrease in the concentration of the drug in this liquid is decreased due to the adsorption of the drug on the surface of this charcoal. Now, if you see, when we will remove the volume of distribution, if you see the equation, when X is equal to VD into C. Now, X is the amount of drug present in the body, C is the plasma drug concentration, V is the volume of distribution, is equal to X by C. Now, if you see, VD is the volume of distribution, which is directly proportional to the amount of drug present in the body and the inversely proportional to the plasma drug concentration. Now if you see, it is inversely, if the concentration of drug is less, the volume of distribution will be more. If the plasma drug concentration is more, the volume of distribution is less. Now you consider this, you consider this container as a physiological model or a body, human body. What happening here? You consider this is the central compartment, where this is the charcoal. You consider it is an extravascular tissue or adipose tissue now. So what happening here? The drug which is present in this plasma will get perfused or penetrate into the extravascular tissue. So the concentration of drug get less in the plasma. So in this case, the concentration is less, the plasma drug concentration is less, volume of distribution will be more. In this case, the drug which get perfused into the extravascular tissue, that may be adipose tissue or the muscles. So in this case, the volume of distribution will be more. So this in this way. Now in this case, we have added the 1 gram of the drug, we convert it into the milligram, that is 1000 milligram, divided, we find that it is 100 microgram per ml. So the drug, that is nothing but the amount of drug which we added, and the 0.1 is nothing but the plasma drug concentration. So we find out it is 100 microgram per ml, convert it into the milligram, so we get the 10 liters. It will get in the ml, convert it into the liter, 10 liters will be there. In this case, we find the concentration is reduced to the 50%. So the 50 microgram per ml converted into the milligram, put in this formula, you will get the 20 liters. So this is the difference. Here we are getting the 10 liters. Why? the concentration is more, volume of distribution will be less. In this case, the concentration in the plasma is less, the volume of distribution will be more. So in this way we can find out the volume of distribution. Now we'll see what are the application of volume of distribution. The application of volume of distribution, it is used to estimate in the loading dose. Secondly, it is used in the case of clearance to estimate the clearance. So now if you see the equation of clearance is equal to Vd into Ke, elimination rate constant. So from this we can find out the volume of distribution also, and in the case of clearance also. Next application of this volume of distribution is to find out the amount of drug present in the body. Then next advantage is that the volume of distribution is used in the designing the multiple dose regimen. Now we'll see what are the factors that affect the volume of distribution. So the extravascular fluid that affects the volume of distribution. Next is the tissue perfusion that also affects the volume of distribution. More will be the perfusion, more will be the volume of distribution. If this is an extravascular tissue, more drug will be perfused in this extravascular tissue, more will be the volume of distribution. Less it will be perfused, more will be